Airtightness. Many different ways of achieving airtightness for different products. Here we have this, which is representing an RSJ, a roll steel joist, or a piece of steel support. How do we airtight around that? Well, if it's a new build, you can actually wrap the airtightness membrane around the end when you put it in. And then you can fold it back and it forms a pocket or a sock around the end. It's a little bit different when you come to retrofit, where we've got to actually tape to an airtight to an object, which is already there. We can't take it out, we can't replace it. We've got to work around what we have. Well, there's a number of different methods to which we're going to use. Firstly, if we just take our membrane to the steel in this circumstance, and then all we can do is tape around this edge, which is great, works a lot of the time, but we're going to go through another method as well on the other side, just to show you some variances of what we can do to achieve airtightness. So I'm actually going to use, on this particular side, I'm going to use a standard duct tape, because if I was to use the blue TESCON tape, I'd never get it off again. And the idea is we can actually take this to bits and reuse. So at this circumstance, I'm just going to use a bit of duct tape. So all we're going to do is we've already membraned up to around the steel as neat as we can. And we're only gone to the steel. We haven't overlapped this yet. Only the overlap on the vertical cut. No. All we're going to do, go to tape to the steel, to the membrane. So what we're trying to do here, we're trying to keep it nice and tight. But like with everything else, you can't actually make all the folds. Sometimes you have to cut it, which is what I've done there. I'm onto the steel. I'll do another one here. So what I'm going to do, I'm going to put the tape onto the membrane and onto the steel, making sure that's really tight into that corner. Then you have to cut this, keeping it in one piece as best as possible. So we've got an overlap here, overlap there. Here, we've just got a straight joint. So then what we would do, we come onto the steel the same distance, fold that really tight into the corner, cut to the steel, we fold this. Making sure all the joints are tightly squeezed together, run your finger over, making sure that's really tight to the steel. And those corners, those overlaps are really compressed to make sure that there's no breakdown of that joint. We repeat that process on every corner and every surface. Now, again, you can't take a tape into an internal corner and expect to stretch that tape over the external part of it. So we cut in square to the corner, and as before with other air tightness details, we use a smaller piece. go right into the corner and allow that to fold in. One effect we've done there is we've gone right over all the joints with one piece of tape and made sure we've got really good adhesion on that. And you get a nice airtight seal. Again, corner in, working your way out. Okay, so all we've done is we've been tello or air membrane cut around the steel as tight as we can, and we've literally just lapped onto the steel and the tello, the air tightness. And we've gone in straight lines, cutting the corners and folding them round, and then reinforcing it with another piece of tape over the top to cover those corners. This is, you can actually achieve a really good air tightness detail with this. Not my preferred method, but it does work, and you'll get an airtight seal with that.
John, you referred to a vertical cut, and as you was putting the tape along the top and then a vertical. Just go through that detail again, because I think it's quite an important detail.
But yeah, two different directions, vertical, horizontal. Regardless of we term it as that, but the steel could be on the angle, could be at any angle, but the process will be exactly the same. So what effect I've done is I've gone in a straight line, folded it into the corner, and I've cut this just to fold in tight to the corner. And then I've used another piece vertically to go over that. So basically we're going to do this effect. We're not going to try and stretch the tape over. Every time we stretch that tape and try and force it into a joint, that does two things. One, it stretches the tape, which potentially causes the tape to be able to breathe. It's a material tape at the end of the day. If you stretch it, you take away some from that air tightness value of it. And also, what you're doing is you're putting it under pressure. You're putting it under stress. So when we come to do the air test, if they do a negative air test to suck the air out, you could potentially get breakdowns where the tape would separate or the membranes would separate under pressure.
Excellent. So just reiterating that we are using the tape for demonstration purposes only.
Yes, the black tape is just for demonstration purposes, because once we use the blue tape onto this, we'd never get it off.
Yeah. Yeah, so in theory, that's the blue tape.
That would be.
So in practice, when you're using the, I'm going to call it conventional tape, what sort of limitations does that have if someone were to practice using that tape? What do they need to think about? How is that tape different to the TESCON tape, for example?
Well, as with the TESCON tape is obviously a lot stronger adhesion. This pulls off. I can pull that off now with no problem at all. Is for demo purposes only. The blue tape, the TESCON tape that we use is, as with the majority of airtight tapes, the adhesion strength of those is much stronger. So it pays to take a bit of time, a little bit of attention to what you're doing, because sometimes when you had it on, if you make a mistake, you can't get it off again. You would have to go over the top of it with another piece, and you'd build up layers. So it's the adhesion strength which is the difference.
Yeah, and we've positioned that steel, in theory, at head height. It's very convenient for you to demonstrate. In practice, from your experience and the knowledge that you have, how might this be in actual practice?
Well, there are times this is like this because you'll have a supportive steel coming in to support a wall above, or there could be a purling steel, or it could be a ridge beam. Could be anything. The process is going to be the same regardless whether it's steel, timber, or whatever. The answer is could be anywhere.
So it could be at the floor,
It could be at the floor level,
or high into the ceiling
level. Could be roof level.
Yeah.
Could be within the roof. So this is what I'm saying. It can be at different angles, different sizes, but follow the same principles regardless of the size, shape, product, or anything else. The principles are what you need to follow.
Yeah.
And
And I suppose the principle in theory is quite easy, but in practice it could be very challenging because
it can be.
it's tucked away fully on one spot.
It can be challenging. What you need to do is just have a piece of patience and follow the basics. As long as you take your time and you follow the basics, there's nothing quick about air tightening anything. It has to be done very methodically. You can achieve some really good results with the methods to which you can see, but it needs to be done in a controlled way. Not everybody can do air tightness because they just don't have the ability or to be able to do it. But you have to have a piece of patience, take your time and do it methodically, because the better you do the job the first time, the less likely you are to have failure or a breakdown. And that takes time and that takes money to repair. So get it right the first time. Do not rush air tightness.
Excellent. Thank you, John.